All right, tonight what we're going to be talking about is how to do solution stoichiometry. So instead of using that 22.4 conversion, we are now going to be needing to use molarity. All right, so the first thing is let's read the problem, figure out how our stoich map goes again. How many milliliters of 0.2 molar NaOH? So for this guy, I'm going to write down question mark milliliters, but I do know something about it. I do know that it's 0.2 molar. Are needed to react with 85 milliliters, so I know 85 milliliters of a 0.45 molar solution of H2SO4. All right, so my unknown is I need to go 2 milliliters or liters. Okay, so that's where I need to end up. That's where my NaOH is. And then I know I needed to start it from a milliliters or molarity. Well, the only one is we have atoms, grams, liters, liters. So we're going to have to go with that 85 milliliters and start from there. Okay, so the route we're first going to have to do is we're going to have to use this molarity conversion. So 85 milliliters, okay? How do I use that molarity conversion? So we're going to start with H2SO4. Well, what you're going to first need to do is realize that molarity is saying moles for every 1 liter. So when I say I have 0.45 molar solution, I am actually saying that I have 0.45 moles for every 1 liter of solution. So if you notice, now I can go from moles to liters or liters to moles. In this case, I am not even at liters yet, so I need to get to liters. So I'm going to do 1,000 milliliters for every 1 liter of H2SO4. Now we are going to convert from liters to moles using this conversion. So I'm going to put 1 liter of H2SO4 on the bottom, 0.45 moles of H2SO4 on the top. So now we are at moles of substance A. Now I need to get to moles of substance B. For this equation, we're trying to get to NaOH. So I'm going to put moles of H2SO4 on the bottom and moles of NaOH on top. So I'm going to look at my balanced reaction, and I've got 2 to 1. So it's 1 mole of H2SO4 for every 2 moles of NaOH. And now I'm here. And now to get to liters, I'm going to need to use this bridge of, once again, the molarity. So my molarity is 0.2 molar. So that number goes with your moles. So it's 0.2 moles of NaOH for every 1 liter of NaOH. But I ask how many milliliters. So now from here, I'm going to convert from 1 liter of NaOH to 1,000 milliliters of NaOH. Solving this, you get 340 milliliters. Rounded to the correct number of sig figs, which would be 1 because of that 0.2, it would be 300 milliliters. All right, this one. How many grams of water, so I'm asking for grams of water, would I need to react 50 milliliters of 50 milliliters of 1.6 molar of H2SO4. So in this case, I'm going from liters. I'm given the molarity. It's not a gas at STP, so I have to use this molarity conversion, and I'm trying to get to grams. Okay, so the first thing that we're going to need to do is use that 50 milliliters of H2SO4, and I'm going to need to try to get you to use my molarity. So once again, I'm going to need to get to liters, so it's 1,000 milliliters for every 1 liter of H2SO4. Okay, now I'm ready to do that conversion of liters. So once again, that 1.6, I'm going to go over at this side, is really saying 1.6 moles for every 1 liter. So I'm going to put 1 liter of H2SO4 on the bottom, 1.6 moles of H2SO4 on top. So now I'm at moles of H2SO4. Now I want to get to moles of my other substance, which in this case would be H2O. So I'm going to put moles of H2SO4 on the bottom. I'm going 2 moles of H2O because that's what I want to find out about on top. Using the balanced molar ratios, we've got 1 and 2 for water and H2SO4. Now I'm going to need to go from moles to grams. How do I do that? I use the molar mass. So 1 mole of H2O is going to be equal to 18 grams of H2O. Multiply this out and you get 2.88 grams of H2O, but rounded to the 2 sig figs because of that 50 and that 1.6, we're talking 2.9 grams of H2O. And for the final one, it asks for how many milliliters of 3.5 molar H2SO4, so I'm asking for how many milliliters of 3.5 molar are needed to produce 5.8 times 10 to the 25th molecules of Na2SO4. So in this case, I'm going from molecules, and I'm trying to get to liters or milliliters in this case of an aqueous solution. So I need to take this route. So the first number I'm going to write is 5.8 times 10 to the 25th molecules of Na2SO4. Okay, and then I'm going to put 6.02 times 10 to the 23rd molecules of Na2SO4, because I'm trying to get up to here to moles for every 1 mole of Na2SO4. Now I'm going to convert from moles of Na2SO4 because I'm right here and I want to get to here. So I'm going to put moles of Na2SO4 on the bottom and moles of what I'm trying to get to, which is H2SO4, on top. So my numbers are 1 to 1. Now I'm at this point, so I need to use my molarity to get to liters. So once again, that 3.5, that number is going to go with the moles, so it's 3.5 moles for every 1 liter. So I'm going to put the 3.5 moles of H2SO4 on the bottom for every 1 liter of H2SO4. And then I'm going to convert from liters of H2SO4 to milliliters of H2SO4 because that's what it asks for, the unit in. And when you multiply that out, you get 27,527 milliliters, which rounded to the 2 and 2 sig figs. So 1, 2. So that would round to 28,000 milliliters. All right, hopefully you kind of understand, but once again, the difference for this unit is that we were looking at which liters were we trying to get to. Was it of a gas? If so, you'd use that 22.4. Was it a solution? If so, you'd use its molarity. All right, have a great evening.